So let's discuss this GDG, generation data group, how to create it. So to create this generation data group, we use IDCAMS utility. So what is generation data set? Typically, the generation data set is a logically the group of related data sets and in chronological order. Okay, so that means I can create the same, every day the data set name with the what you call data set with the same name. Only thing I will use a relative generation number. That means for a single, what I do is I will create a GDG base. The base acts as a what you call file name for me. The base is nothing but an entry in the system. That's all. It is not a data set. Once you make the GDG base, then you can create a file with the same name by giving a relative generation number. Okay, what is the relative generation number? Current is 0 and the future is +1 and the previous one is -1, -1. So like that relation relatively you can relative generation number you can do it. So that is the idea of having a GDG. So I don't need to create with a different name every day, right? GDG. So and they are functionally same. What do you mean by functionally? Same record layout, same kind of information. Say for example, I want to get the bank transaction details every day. The everyday transaction details are same. So I will create, Monday to Friday, 5 days a week. If I want to go 6 days a week, say for example, 6 days a week, I'll create a six files. So once that weekend is over, I don't need that files again, so I can delete the old files. So these things, like you can create a rule kind of, in GDG. That is what define a GDG with these rules. So then you can create a what do you call you can create a files generation data group files. We call it as a generation data group, right? Okay. So let's see how to create data GDG. So I go to this. I'll open. So for example, I have. So for this, I use what you call uh, IDCAMS utility. Let me check here. Some JSLs I have. So fine. So I'll open another member here. Okay. Okay. Let's see this job. So if I want to create a GDG, so what I ideally will do is like I will use the so the program what I need to use ID camps. ID camps. What this ID camps is? It's basically a access method service AMS access method service which is part of your VSAM. Okay, which is a VSAM services. Okay, so for this utility, I have to have a sysprint, which is a reserved DD name, whatever that like messages generated by the IDCAMS utility that will be printed here in this particular data set. Ideally, we will be pointing to spool. Okay, fine. So next, I'm going to use this sysin DD star, right? I have to, like you want to create a GDG, so I will give the define the parameter, right? So what is that command we are going to use? Define GDG. Define GDG, then name of the GDG. Okay, the name of the GDG I'm going to create with that 56932 dot loading dot. I can create a transaction file, right? Daily transaction. So daily, so DLY dot trans. This becomes my GDG name. Then for the GDG, you have to create, right? So something, like when I create a base, this is a base. But I want to retain how many generations. I mean, like I will run from Monday to Saturday. Then I need a number of generation, like what you call limit here, right? The parameter to limit the number of generation is limit. I want six generation. I can put that six generation. The number of generations, right? So we will give that limit is a parameter and give the number of generation here. The number of generation can be minimum 1 to so maximum 1 we don't ideally do that. So any number highest is 255. Okay. The next we say like empty. So what is the empty parameter? The empty is another parameter which will decide when this suppose you are creating a generation and once the limit is reached, right, six generations are over. What do I do with the oldest generations, previous generations? So it will delete all the old generations, right? The next is scratch. Okay. So there is another parameter, right? The scratch. The scratch, ideally what will happen? It will uncatalog and delete if you given a empty. Suppose if you give a no empty, suppose if I give no empty, that's another parameter. So no empty. What typically will happen is, so it will not, delete that. So no empty and then it will only uncatalog the data set. No empty. Okay, so here typically I will use this, empty and then scratch. So that's all, the parameters. I have only GDG, define GDG, name of the GDG, and like limit how many generations I need, and empty delete the old generations, and the scratch will delete the uncatalog and delete the old generations. This is a parameter. So once I like define this will create a GDG base. So what is GDG base? It's an entry in the system that will control the what you call your number of generation, giving a new generation, right? So now each generation, each time, it is nothing but another file you are going to create using this same name. A PS file you are going to create. Okay, so that PS file is created once created, so that can carry the same name with the generation number, with the generation number. Okay, we'll see that, right? First, I will create the what you call GDG base. Okay, submit here. Okay, so we have to type run equal to hold. I put it here. So I will go to that spool. So this job I will activate here. This will execute. You can see the return code here. The return code is 0, right? So then I will go here. So you can see here the function completed, highest condition code is 0, ID counts processing complete. So ideally what it creates a GDG base. Okay, so step is executed, there is no allegation, de-allegation messages. Now if I go to that, 3.4, the listing, you can see the what you call GDG here. Okay, what is that? Learning daily, right? So I'll put that learning daily. So it is easy for you to understand. So can I edit this? You cannot edit. It will say GDG base. It's only a system entry within like MVS. Okay, so that's called GDG base here. Now, if I want to create a GDG data set, how can I do that? So I have to IEFBR14 and give that new generation I can create. Say for example, I have a data set data set. So what I do is I will create this. Okay, I will take another JCL to create this. So I will have the sys print here. So I want to create a generation data set. So what I need to do is I use IEB FPR14, FPR14. Then I'll give the what you call data set name here, DD1, DD, DSN equal to that same generation, right? So this one, this is the GDG base name, okay? And I'll create a what you call the new generation. That means new generation I have to put that the relative generation number. That's what within bracket I will give. Okay, plus one. So I'm going to create the data set. So I have to give the disk equal to what do you call new data set. It's another PS you are creating. Catalog. So now DCP. I want to create a logical record length with 80 bytes. Block size is 800. Come on. A record format is equal to FB. Then I want to give a space. It's space equal to track, comma 1, comma 1. Right. Next, I have to give the unit. Unit equal to system. Right. So I'm going to create. This will create me a. This will create a what do you call GDG? I mean GDG generation data set. Right. Okay. Abandoned here. IEF. So the data set name is wrong. I mean, sorry, remember program name, what I'm executing is wrong. That's why 806. So now you can see that it is created. Okay, so we'll see that the generation how it's created here. So you could see your generation data set. Okay, what is the job name here? AS, right? I have to open the AS. So you can see the data set is created with, GDG base name with generation. Can you see here generation? The generation number 2 because I last time it ran and it was deleted. So now you have the generation 2, right? It creates with the generation 1 when you run first time. Second time it is generation 2. Okay, let's look at the previous job. So what happened here? Because it would have created that. So in this, okay, this step it would have allocated and deleted. Okay, so cataloged here. So it also created the what do you call previous step, though it is abandoned, it has created a data set. So now we have two generations of okay data sets. Can you see here? This is the one first generation, this is second generation. Okay, the first and then the second generation. So it is normal PS5. So what ideally I do is like I will not change the name here. I'll give the name and then within bracket give the relative generation number. The relative generation number is given here as a plus 1 minus 1. Suppose if I want to refer existing data set, I want to refer this. So we are going to see that. So I have to give the current generation is 0. This is a current generation. This is a previous generation. Okay, I will have to create. So 6 times. So what will happen if I submit it again? Okay. So what typically will happen is it will generate another generation. Okay. Refresh. Okay. Again I will run it. It will create another generation. Okay. So refresh here. The fourth generation is created. Again, if we submit, so I'm not changing the dataset name here, right? Same name is used. So it is every time you run, it is a chronologically a new dataset, right? That's what time bound chronological, right? Submit here. Okay. So now you can see here the sixth generation. Now what is the limit here? Six generations. What will happen if I run the next one? We put a empty. Ideally, what will happen? It has to delete everything, right? Okay, let's see here. Can you see here? All the 1 to 6 is deleted. The new generation is created. This is what once the limit is reached, what will I do with my generation? Delete all those things. That's called empty and scratch. Understood, right? This is how we create a GDG.